Hey everyone, in this video I want to talk about and implement quickly the sentiment analysis based on two very popular libraries, and those are so the first one I'm going to use is this one, TextBlob, and the second one is a module of the super popular NLTK library. So that's nltk.sentiment.vader. And the data set, for the data set I'm just picking one relatively small data set from Kaggle that's called sentiment analysis movie review. This is kind of only half a kilobyte, so it's pretty small database, so we can do this thing very quickly. And of course I will give the link of the dataset in the description section of the video. And so in this first cell I have already downloaded the data in my local machine, and so here I'm just reading that with read CSV. And because it's a TSV file, that is .tsv, so I have to include the sep equal to \t. So this is the data set, this is the data frame in the TSV file. So what we have mainly, what the column that we are interested in is this column, phrase. So this has various text, and let's quickly apply our sentiment analysis on this. And also another quick thing, that ideally in the actual scenario, when working with real data, before applying the sentiment analysis technique, you should be doing some pre-processing on the textual data, like lemmatization, stemming, lower casing words, cleaning the data, of course, removing stop words, tokenization, etc., before applying the sentiment analysis. But here I'm going to skip those steps because the focus of this video is just the sentiment analysis. So the first thing I need in this data frame is another column which will hold the text scores from the TextBlob library. And I have already imported this TextBlob, import TextBlob. So let's define a function to add that column. Sentiment df. Just declaring a list, and that list will be filled up through a loop. X in range, and my range is 0, and also df dot shape 0. Text blob, and to that I'm passing df dot integer location. Let's take x and also 2. Here I want to capture the sentiment, so I have to do quant text blob dot sentiment. So these sentiment property here returns a named tuple. So if you go to the documentation of TextBlob sentiment analysis, here in this this section, the sentiment property returns a named tuple of the form sentiment, polarity, and subjectivity. The polarity score is a float within the range -1 and 1, and the subjectivity is a float within the range 0 and 1, where 0 is very objective and 1 is very subjective. So basically subjectivity quantifies the amount of personal opinion and factual information contained in the text. The higher the subjectivity score, that will mean that the text contains personal opinion rather than factual information. And yeah, so let's go to our sentiment. That's the name of the new column that I'm going to need, and that will be equal to sentiment tuple. Return df. Now I'm just going to invoke that that method. So train df is my original df, this one. Awesome. So I got this new column added with the score, and now I want to create another new column that points only the polarity score. It just I'm constructing a data frame which will have the the relevant numbers of sentiments in my data frame itself. So what you can do is just create another method. So here my purpose is to create another new column that prints only the polarity score, which will measure how much sentiments is there. So again, this polarity score varies between -1 and +1, and -1 defines a negative sentiment and 1 defines a positive sentiment. Simple. So now I'm going to add another method. Exactly the same structure. I don't need that to I could just actually just copy and paste the previous function anyway. When I've started writing, just complete it. df dot x and then 2 measures. And TextBlob dot sentiment. Only difference is here. After sentiment, I can do another dot polarity. That will get my polarity from the tuple. Polarity list dot append measures. And now df polarity. Yeah, so now I got another column added with the polarity score. Okay, so that was about TextBlob, and now, so just on the significance, on the interpretation of this number. So here I got polarity of 0.7, which means that it is a positive text, that is, it's a positive sentiment. And subjectivity of, say, for example, this one 0.399, which shows the opinion of the user is slightly towards a subjective view and not exactly completely fact or data driven. It's kind of an opinion, and because it is closing towards a 0.5 value, but still it is on the lower side, it is not too subjective. Okay, now I'm going to use Vader. So this should be a markdown cell. So This Vader stands for Valence Hour Dictionary for Sentiment Reasoning, and it is a model used for text sentiment analysis that is sensitive to both polarity, that is a positive negative, and intensity, that is strength of emotion. And Vader belongs to a type of sentiment analysis that is based on lexicons of sentiment related words. Yeah, basically these lexicon approach means that each of the words in the lexicon is rated as to whether it is positive or negative, and in many cases how positive or how negative it is. Yeah, so now the actual code, it's part of the super famous NLT case, so I need to import that also from dot sentiment. I think this is the one, yes, as VAD NLTK dot lexicon. Okay. Just making a copy of the original one. Actually, I think I should read that initial sentence again, initial .csv file again. Otherwise, it will be, because many new columns were added. So let's just read it fresh here. Yep, now it's fresh again. So now I'm going to, I'm making additional columns for sentiment scores, just like I did previously for the TextBlob library. But here I'm not going to create a new method. I'm just doing in the cell directly. So the new one I need, let's name it positive, negative, and neutral. Sentiment. This will be a list. Score I for I in Vader ph. It was phrase, right? Yes, phrase. And now just define the new columns. So equal to get it for on in sentiments. On sentiments. Similarly, the last one will be neutral. Okay, I need another one for computed score. Actually, it's a compound. And score. Okay. Score. Score. Let's define the condition. If I greater or equal to 0.05, then t dot append am I doing it right? Yep. Missed the I. Okay, t dot append positive. Now the next condition, if I less equal to no 0.05, then t dot append negative. And the last one, else neutral. Oops. Finally, for their overall sentiment equal to t. All right, let's run this cell. What is that? I got compute score. I must have, yep, compute compound. Yeah, that cell ran properly. Now just check this data now, my data frame, Vader.head. Awesome. So now I have these extra columns all added: negative, positive, neutral, and compound score, and overall sentiment as well. So this overall sentiment is what we calculated in this loop over here. Okay, looks awesome. Now as the last step, so this was just a simple way to show that how to get the sentiments and also create new columns from your textual data frame, that is from your text original training data set, and add the relevant columns which will be later fed into further level of analytics or your final model. So I definitely need to add at least some minimum graphs to check that the distribution of these various sentiments in our training data. So let's import few things. Express as px. I'm going to plot a histogram, so px.histogram. To that I pass data frame. Okay, and in histogram, rows of data frame are grouped together into a rectangular mark to visualize the 1D distribution of an aggregate function, histfunc, okay, of the value y, x. Okay, so the first one is data frame, it can take, and then I also need to pass x and the y. Okay, let's continue. That will be my data frame. My x is my computed compound score, POUND, and y will be my overall sentiment, so that I can see that what is on the y-axis. I can see the four different colors, or rather the three different colors for positive, negative, and neutral. and on the x-axis I will see the actual score. Okay, I also want to mention the color. Color argument will be overall sentiment, and template I'm just giving it as plotly. Okay, I actually wanted okay, no, looks kind of all right. So what we see, actually the plot does not really look the way that I wanted. I think I have to modify here. X is my compound score, and what I'm getting, sum of compound score. Okay, so this is not what I wanted. Okay, let's and Y, I don't think I need the Y argument here because I'm giving color anyway. And okay, let's run now. Yes, that's how I wanted. So what we see is on the x-axis all the actual compound score, and on the y-axis our sentiment, and we can see that most of the sentiments are neutral, which is what is expected in a normal situation. All right, now I want to plot another quick plot which will show the overall sentiment. So I want to import Seaborn. Oops, sometimes this auto intelligence works beautifully and sometimes they don't, as SMS. So I'm using tab 9, and tab 9 really works great most of the time, but sometimes it doesn't work. SNS dot count plot. I'm going to count the overall sentiment right there, and what was the name? I need to tag this one, overall sentiment. Yeah, so that's a overall distribution of positive, neutral and negative, and obviously we can see the neutral are the ones which are the most, and I have 600 neutral ones. And remember, total number of rows that I selected at the very top was 1000. All right, that pretty much wraps up this video, and stay tuned because all my future videos over the coming days and weeks will be some great, interesting NLP related projects, especially some Hugging Face related projects using Transformer to do many of them. All right, thank you very much for watching, and see you in the next one.